Hello everyone, my name is Bient-Nelhumpson Lahaman and I'm the reporter of number 18. And my topic title is Simple Harmonic Motion, String Mass System, Simple Pendulum, Physical Pendulum, and recognize the necessary condition for an object to undergo simple harmonic motion and calculate the period and the frequency of the spring mass and simple pendulum and physical pendulum. Today, we're going to talk about simple harmonic motion or SHM. This is type of back and forth motions that around the center point called equilibrium. Lots of things moves like spring, pendulums, and even objects swinging on pivots. For SHM or simple harmonic motions, two things need to happen. The first one is restoring force. There's a force pulling object back to the center, and the second one is proportional force. This farther it's moved from the center, the stronger the force pulling it back. So, we'll go over simple harmonic motion or SHM in three systems. The first one is spring mass, simple pendulums, and physical pendulums. And I'll show you how to calculate their period or the time to pull the cycle and the frequency of the cycle per seconds. The first one is a spring mass systems. It's just a mass on a spring. When you pull the mass and let go, it moves back and forth. For the period t, is the time for one full cycle it depends on, where the t is equal to the 2 pi the square root of m over k, where the m is the mass and the k is the strings stiffness. For example, we have the mass of 2 kg and the spring constant has a 50 Newton meter. Then we just simple substitute it and calculate. T is equal to the 2 pi over the mass, which is 2 kg, and over the all over spring constant or K, which is 50. So when you calculate it, 2 pi the square root of 2 over 50, it will give you the approximate value of 1.26 seconds. So its cycle takes about 126 seconds for one cycle. So another system is a simple pendulum. It is a mechanical system that consists of mass referred to as a bob or suspended from a fixed point by a string or rod or nelightable mass of fixed length. These systems allow the bob to swinging free in an arc under the influence of gravity. The motion of the simple pendulum can be analyzed using the principle of classical mechanics. It's particularly focusing on the concept of periodic motions, forces, and energy. So the simple pendulums, the periods depend on the t is equals to the 2 pi the square root of length over the gravity, where the L is the length of the string measured in meter, and G is the gravity, which is obviously 9.8 meter per second squared. So let us hear example. If the length of string is 1 meter and the gravity is 9.8 meter per seconds, then we can calculate it as the T is equal to the 2 pi over the mass, over the 1 meter over the gravity, which will give you the value of 2.01 seconds. The last system is a physical pendulum. Physical pendulum is a mechanical system that encompasses a wide variety of rigid bodies swinging about the fixed axis due like a force of gravity. Unlike a simple pendulum, which is characterized by a point mass attached to the Mises string, the physical pendulums includes any object with a defined mass and shape. This introduces the layer of complexity as a distribution of mass within the object influences its motions and behaviors. So the physical pendulums, the period t depends on the t is equal to the 2 pi the square root of object inertia over mass times gravity times the distance. So let's hear some example. Example for the mass of the object has 3 kg and its inertia 0.75 kg meter squared, and the distance between the two objects is 0.5 meter. So just simple substitute it. T is equal to the 2 pi and the square root of the inertia of an object, which is 0.75 kg meter per second per meter squared, all over the mass, which is 3 kg, and times gravity, which obviously 9.8 meter per second squared, times 0.5. If you calculate this all, it will give you the approximate value of 1.99 seconds. In conclusion, simple harmonic motion or SHM is a fundamental concept describing in repetitive back and forth movements seen in systems like springs, pendulums, and the other oscillating objects. This motion is driven by the restoring force that pulls object back toward the center pulse, with the force growing stronger as the object moves farther from the center. Each system we look at the spring mass, simple pendulums, and physical pendulum has its unique factors like mass, spring, stiffness, length, or distance from the pivot that determine the period and the frequency, and understanding SHM or simple harmonic motion is valuable because it helps us predict the design movement of everything from chocks or the bridges, and even the behavior of waves and vibration across various scientific and engineering fields. So again, I am Bient-Nelhumpson Lahaman, the reporter of number 18, and thank you.